Okay, today topic is pointers. So before going through the concepts of the pointers, I would like to give a brief introduction. The pointers are address variables. We know that the code is or the program is saved in the code segment. However, those programs cannot access the data in heap. It can directly access the data in stack, but it cannot directly access the data in heap. Therefore, the programs use pointers to access the data in heap. So that is one of the major reasons we are using pointers. In this example, we create a pointer called p in stack. And then we create another variable in the heap. So what we are doing is we save the address of that variable of heap in the pointer p. So in this pointer, we save the address of this variable. Therefore, it looks like this pointer p points to this variable. There are several advantages of using pointers. As we discussed before, accessing heap is one of the advantages. And also we can use pointers to access the external resources like hard drives, internet, modems, and etc. And also we can use pointers to pass the parameters and also for dynamic memory allocation. So here you can see an example code. I'm showing only the main function of that code here. So if you look at this main function, you can see there is a variable called num with the data type int, and we store the value 28 in this variable num. After that, we declare a pointer called p using this star mark. So if we put star before the variable name, it becomes a pointer. And this is a pointer with variable type int. After declaring the pointer, we save the address of num variable in that pointer. So if we put Anderson mark before the variable name, that means we are getting the address of that variable. So we are getting the address of variable num and we save it in the pointer. So in this code, I'm printing the value of the variable called num, and also I'm printing the address of that variable. So here you can see that I put the percentage mark %d inside this printf because I'm printing a numerical value. However, here I'm putting the percentage mark P in the second printf, because here I'm printing an address. So addresses are hexadecimal values. Therefore, I have to use this P parameter. Okay, so this shows what I'm doing here. So again, I declared and initialized the variable called num with the variable type int, and then I declared a pointer with pointer name P using this star mark, and then here I retrieved the address of the variable num using this & mark, and then I print the values of variable and also the address of the variable num. So you can see the value of the num variable and also the address of the num variable. Here you can see this is a hexadecimal value. The addresses are hexadecimal values. That's why I'm using P in this printf. Okay, so if I use a diagram to show this, so this is how it happens. The program will allocate some memory for num variable in the stack, and it will store the value 28 inside that num variable, and also it will create or it will allocate memory for the pointer in the stack, and then it will save the address of the num variable inside this pointer. So it's like a pointer points to this num variable because this pointer has the address of the variable. Okay, so in addition to the printing the variable value and the address of the variable, here I'm printing the value of the pointer and also value of the variable. So so in this example, we have price variable and the pointer, and I'm storing the address of the price variable in this pointer. So you can see I'm using the name of the variable to retrieve the address of the price variable. And if I use the star followed by the pointer name, that means I am retrieving value of the variable. Here the variable is the price variable. So this one prints the value of the price variable. So you can here I am using D because this is a numerical value, and here this is an address of some location in the memory, so it should be P. There should be P in the printf to print this value, and here again I'm using P because I'm printing an address, and here I'm using D because here I am printing the printing a numerical value. So you can see if I run this code, I'm getting this output. So price value is 2,500. That's what I saved in the price variable. And then and Anderson mark followed by price gives us the address of the variable price, and p pointer prints gives the address of the price variable because that's the value of it. And then if I use star p, then I'm getting the value of the price variable, because the pointer p has the address of the price variable. Okay, another important thing you must understand here is, when we are declaring a pointer to save the address of another variable, then both the variable types must be matched. So here the variable type of this variable is float, then the pointer's variable type must be float. If we are using int variable type, then it will give us an array. It will give us an error. So here we have a char type array, because this is a string value, and we cannot use int type pointers to save the address of this string. Okay, to correct it, I have to declare this pointer as a char variable, and also I have to create an array. So we are declaring it in this way. Here you can see I made both pointer and the variable float type variables and pointers. Okay. Next thing is about the pointer arithmetics. So we can operate increment operator on the pointers. So normally, if I operate increment operator on a numerical variable, that means I'm adding 1 to the value of that variable. However, this is different than what we are getting from the numerical variable. I mean, operating increment on pointers operates in a different way. So you can see that we have this pointer, right? In this example, we have this variable called num with an int data type, and then we have this pointer within data type, and then here we save the address of this num variable in this pointer, and we are operating increment operator on the pointer. So then what happens is the program will add size of the data type to this variable p, or the pointer, the value of the pointer. So it is like p is equal to p plus size of int. So for convenience, I'm assuming that the address is 2400. Address of the num variable is 2400. So if I operate p plus plus, I'm getting P is equal to 2400 plus 4. That means 2404. So this is how it works. I'm adding 4 because in my computer the size of the int variable type is 4 bytes. So I'm adding 4 to the address of the num variable. So in this example, I'm printing the value before increment operator operates on the pointer P, and again I'm printing the value stored in P after operating the increment operator. So let's see what happens. So before operates the increment operator, the value is this long number, and after we run this P++ statement, I am getting this value. So you can see how it works. So if I add size of int variable, date type, size of int date type, I'm getting 4. So if I add 4 to this number, this long number, I am getting this value. So you can, by comparing these last digits, you can see it clearly. And also we can operate the decrement operator on the pointers. So again we have this pointer P, and again I'm assuming that the variable num has the address 2400, and I operate decrement operator on P using this P minus statement. So what happens is it reduces size of int from P. So size of print of my computer is 4 bytes. So 2500 minus 4 means 2396. So here in this example, what I'm doing is first I print the value of P. That means the address of this num variable, and then I'm operating P++ operator or statement, and then I'm running P minus minus, that means decrement operator. So, and I'm printing the value of P after each operation. So you can see first the decimal value of this decimal value of the address of this num variable is this, and after incrementing I'm getting this value, and after after operating the decrement operation, I'm getting back to the previous value. So you can see this value increased by 4, and again the after the decrement operator it will decrease by 4. So here you can see an example with long data type. Okay, next thing is addition. So you can add some number, some integer number to the value of a pointer. However, it does not work like addition of the numerical values. Now, if p is a numerical value, then we just add 6, but it does not work in the pointers. So p plus 6 in this case is p plus size of the data type times 6. So if I run this code, it will print the value of the pointer before we add 6 to the pointer, and also it will print the value of the pointer after adding 6. So this is the value from this first printf statement, and this is the value after adding 6. So you can see size of long is 8. I mean, in my computer it is 8, and then we are multiplying it by 6. So we have 48, and if I add 48 to this number, I'm getting this. So you can compare these last 3 digits and see this is how addition in the pointers work. Okay, you can also do the subtraction. So if I reduce 6 from the value of pointer, this is the operation actually works. So it is p minus size of the data type times 6. So if you run this code and if you print the value before the subtraction and after the subtraction, you will see that it will reduce 8 times 6 from this address of the num variable. So we learned how to do the increment, how to operate increment and decrement operator, and also we learned how to add some number or add some or subtract some number from a value in the pointer. And then we can also do the subtraction of 2 pointers. So in this example, we have p1 and p2 pointers, and py points at num1 variable, and then I'm adding yeah, you can neglect that. So here what I'm doing is I'm subtracting value of p1 from p2. So actually what performs is it performs this operation. So p2 minus p1 means the value of p2 minus value of p1 over size of the data type. Here the data type is long, so it is size of long. So if you run this code, you will see that you will get 64. right? 64 as the result, because I'm printing the result after subtracting P2 value in P2 from the value in P1. So I'm getting 64 because the difference the difference between these two addresses is 512, and the size of long data type is 8. And if I divide 512 from 8, then I get 64. There are some arithmetic operations are allowed, as we discussed before. Those are adding an integer to a pointer, subtracting an integer from a pointer, and subtracting a pointer from another pointer. However, some arithmetic operations are not allowed. Those are adding 2 pointers, multiplying 2 pointers, and dividing 2 pointers. So next thing is passing pointers as arguments. So in this example, you can see how we pass a variable values normally, right? So here we have a cal underscore price function, and we are passing a and b values to this function. So these are the arguments, and the price, we have this double type price variable, and it is equal to 0.6 times value of a plus 0.4 times value of b, and we are printing the value here. So in the main function, we have these two variables, and we are passing the values to this cal underscore price function. So this is a normal and simple code you can understand. However, we can pass the pointers as the arguments. So here the arguments are pointers. This a and b arguments are pointers. So if we pass the addresses of some variables, we can retrieve the values of those variables using these pointers and use and perform these calculations. So in the main function, I declare and initialize two variables called a and b, and I pass the address of a and address of b to the cal underscore price function. And also you can perform comparisons using these comparison operators, like greater than, less than, greater than or equal, less than or equal, equal, and not equal. So in this code, we have several variables, and we pass the, or we store the addresses of these variables in these pointers, and then we retrieve the value of the pointers using this star mark, and then we compare the values of these variables. So it is easy to understand. Only the thing you need to understand is if I use star mark before the pointer, then I am getting the value of the variable uh, uh, to where it points. So that is the main thing you need to understand. So here you can see the some information about pointers of the arrays. So first of all, this is just a normal array, which is called ARR. It has 5 components. So those are 1, 2, 3, 4, and 5. And then size of the array is the size of the data type times number of elements. So size of int in my computer is 4, and number of elements of this array is 5. So the size of the array is 4 times 5, 20. So the size of array is 20 bytes. Okay. So here we have double type array. In my computer, size of long data type is 8. So 4 times 5 means 20. So it is 20 bytes. Okay. Now remember that the name of an array represents an address over pointer. An array name is the address of the first element of an array. Normally, pointer can take different addresses. However, the array name is a constant pointer which takes only the address of the first element. So here in this code, I declared and initialized this ARR array with 5 elements. And then I have 2 pointers here. One is called P, and other one is called Q. So here I assign ARR, value from ARR, or the array name, to this pointer P, and here I'm assigning the address of the array, address of the first element of the array to the pointer Q, and I'm printing the values of both P and Q. So let's see what I get. If I run this code, I'm getting this output, and you can see that both printf statements print the same value, because array name represents the address of the first element of the array, and also Anderson mark array name and the 0 index gives the address of the array, first element of the array. So both represent the same thing. Now, if I operate this increment operator on P and Q, again what happens is it will add size of the variable type to the value of P. The value of P was address of the array address of the first element of the array. So it will add size of int to this value, and Q++ is also giving the same thing. So here you can see that I'm printing the P and Q values before operating the increment operator. So initially we get this value. We get this value. However, after operating the increment operator on both pointers, I'm getting this one. So you can see it added size of int, that means 4, to this address. So size of int is 4. So therefore, by using the for loop, we can move from one element to another element in the array using the pointers. So here you can see an array called X, and it has 1, 2, 3, 4, 5 elements. And then I assign the address of the first element to the P, and I use this for loop to go from one element to another. So here I'm printing the value of the variable to where this pointer points. So that means initially it is the first element of the array, and then if I operates a P++, it will go to the other one. So likewise, I get all the values of the elements in this array. So if I run this code, I get 1, 2, 3, 4, 5. So it is happening because pointer increase its value in this way. Always goes increased by size of the data type. That means it goes to the other element of the array. Okay. So next, so in this example, we have ARR array, and we declared the array of pointers. We declared array of pointers here, and then I assign the address of the array to this pointer. Address of the array to this pointer. So this is not like before now. So if I go back to this example, I just use the array name, okay, because array name represents the first element of the array. However, here what happens is I am using this underscore mark before the array name. So now this is a different scenario. This Anderson mark array means it represents whole array. So therefore I have to declare this pointer as an array. Okay, now here I have the int array, ARR array, and then I declared this pointer as an array, and I assign the value to this pointer using this Anderson mark ARR. And then I operate this increment operator on P++. So this is how it works. So if you run, you will get this kind of result. And what happens here is it adds size of array to this initial value. So size of array means size of the integer value or size of the data type times the number of elements. That means 20. If I add 20 to this number, I am getting this, right? You can compare these last digits with this number. So you see that it added 20 to this. It is because the size of array is 20 in this example. Okay, so that's all we have for the pointers. So hope you understood the important details of the